If you want to install subwoofers into a truck, one of the best locations to install them is under the rear seat. This location often gives us plenty of air volume for a well-designed shallow mount subwoofer. And with available seat lift kits, we can get even more air volume to work with. Now currently here on the channel, I am working on building a custom truck subwoofer system that is going to feature 3 JL Audio 13 TW5s. Off camera, I took some dimensions and determined that without a seat lift, I would have enough airspace to run 2 of these subwoofers. But like I mentioned, we know that we want to run 3 of these, so I did choose to do a 2.5-inch seat lift in order to gain more room. So what does the design and planning process look like for creating a custom underseat subwoofer enclosure? Let's dive in. Before we can get into the design, like I mentioned in the intro, it is critical that we have proper dimensions to work within. Previously on the channel, I made a full detailed video all about how to find these initial dimensions. Also included in that video, I discuss how you can approximate air volume. That way you make sure that you don't pick subwoofers that simply aren't going to have enough air volume under your seat. So if you haven't seen that video process, at the end of this video, I'll have a link for you guys to check out. So now that we know the space that we have to work within, we can begin to plan out our design. But really quick, don't forget that a great way to plan out the rest of our system and pick all of our gear and know what is compatible with our vehicle is to check out our show sponsor, Crutchfield. On the Crutchfield website, you can enter the year, make, and model of your vehicle, and for qualifying vehicles that they've researched, you can find out exactly what gear is going to fit. Crutchfield will also help you determine exactly what speaker brackets, wiring harnesses, fit kits, etc. that you need to install that gear. Better yet, you can save on your next car audio purchase with Crutchfield by checking out the special CAF fan links down in the video description. Let's head on over to the computer and check out this design. So here it is, my friends. If you guys have watched my design videos before, you know that I like to always start with the finished project. That way you guys can see what we are working towards once we start stepping through all of the design details. So here it is. Here's our enclosure. If we flip it over, obviously the top is going to be a solid piece of wood. It won't be clear like this. I just made it clear here in the model so that you guys can see inside, but you can see there are 3 subwoofer cutout holes for our 3 13 TW5s. And I think the best way to begin is just to look at this from the side profile and realize that this is simply just a underseat wedge style shape. You do see that there's a notch here. We'll talk about that more shortly, but overall we just have this one angled top face. Now where things start to get a little bit more complicated though is if you look at these front corners of the enclosure, you can see that these are rounded. This really becomes apparent when we look at a top view here. You can see those 2 rounded corners on the front side of the enclosure, and the reasoning for this is because the seat itself in the vehicle, it doesn't have a sharp 90-degree corner, it has a rounded corner, so we want to match that profile. Looking at the side of the enclosure again, the reason for this notch here is just because in the vehicle there's a small little notch on the floor, and by having this notch in the enclosure, it doesn't actually eat into any of the air volume. Instead, this notch actually just cuts away part of the side area here that is being used to raise the subwoofers off the floor anyhow, so no big deal there, and it's just going to give me a little bit more clearance over a little raised lip in the vehicle, allowing this back wall to extend a little bit further underneath of the seat. Now, just in case you're wondering, the reason that we went with downfiring on these subwoofers rather than upfiring them into the seat is typically in a truck application, you're going to find that loading that bass wave, if you will, loading that sound wave off of the floor is going to result in better sounding bass. Now, this isn't always a hard rule. It can be different from vehicle to vehicle. I recommend building a small test enclosure that is just really simple, 6 sides, before you ever build out a full complex enclosure like this, just to test and make sure that you like your orientation. But in this case, like I mentioned, we are going down firing rather than up firing. What's important when we are doing a down firing enclosure is we do want to make sure that we have enough clearance from the floor, which is this surface here, to the mounting surface of the subwoofers. We want to take into account the fact that the subwoofers themselves have a thickness, and we also want to take into account the fact that the cone of the subwoofer and the surround is going to move the amount of the excursion of the subwoofer. We obviously don't want the subwoofer slapping the floor of the vehicle, so this is going to be an important design detail to pay attention to. Now, if we look at this enclosure from a bottom view, you can tell that on this baffle, the baffle is the piece of material that the subwoofers actually mount to, you can tell that a lot of the material is removed simply because we have to have those cutout holes in the baffle for the subwoofers to actually go inside. Because we've removed so much material from this surface, it is a good idea to tie this surface to another surface to strengthen it and to tie it to some of the other sides of the enclosure, and that's why we have these internal window braces on the inside of the box. Even with the top of this enclosure being a large solid piece, it is a good idea, since it is such a large spanning piece, to have those braces there as well, just to strengthen that all up. This is going to make our enclosure really good and strong and avoid any resonance issues. Now, you're also going to notice that there is a cutout on the front of the enclosure underneath here. That's just to allow some of that energy from the subwoofers to transfer into the cabin of the vehicle. We also kind of have a raised cutout on the back side of the enclosure here. What I really want to point out, and this oftentimes gets brought up, this isn't going to be sealed to the floor of the vehicle. It's not like we have an airtight seal here, so that energy transfer is going to be able to occur even though we are so close to the floor of the vehicle. And that's another thing worth bringing up. A lot of times people ask with a downfiring enclosure, hey, don't you want more space between the subwoofers and that surface? Ideally, yes, if you could have more space, that would be great. But the problem is, obviously, if we raise these subwoofers even more, then we're losing our much needed air volume inside the enclosure that we need for the subwoofers to properly operate. Now, while we're on the topic of air volume, before we begin the design process, we of course want to have an idea what our target air volume is going to be. In this case, this is obviously a sealed subwoofer enclosure that we're making. So let's check out the specs here, and it looks like we want to target a sealed air volume of 0.8 cubic feet per subwoofer. So we have 3 subwoofers, so our goal is going to be 2.4 cubic feet of air volume after all displacements. Let's discuss that during the design process as well. A quick side note, another one of the things I really like about the Crutchfield website is they always give us easy access to the owner's manual in PDF format. So once I've clicked that, we can also find some important measurement details. So once we've clicked that, we can of course usually find some important dimensions that we're going to need for designing our enclosure. Things like the mounting hole diameter, that's the cutout hole in the baffle. Also the outside diameter of the subwoofer. This particular subwoofer is kind of unique in that case. We'll talk about that more in a second. And we of course are also going to want to pay attention to the mounting depth. This is critical for underseat enclosures. So let's roll back our design history here to our very first step. And this is where I create the overall profile for the subwoofer enclosure. Now, based upon some of our initial dimensions that we've already taken, we know we want a 54-inch width and a 14 3/4 inch depth. So I've got those values in there, 54 and 14.75, and I've also added in these rounded corners. Now, the reason I haven't just drawn a simple round over there is because I want to actually stack these corners up. I'm going to be using some of the Mobile Solutions quick corners, which have this profile here, which will allow me to easily create a stacked rounded profile for the outside of the box. So based upon this initial profile, what I've done is I've extruded some of those rounded pieces, and I've extruded these to a height of 1 3/4 inches. The reason for that is I took some measurements of my subwoofer, and it's about 1 inch from the bottom flange of the subwoofer to the tip of the surround. And then I know the excursion of the subwoofer, that's in my manual right here, it's about 0.433 inches. So I know that worst case scenario, it's going to be about 1.433 inches that surround is going to come away from the mounting surface of the subwoofer. I know that this surface is going to be the floor of the vehicle, and I know that this surface here is going to be the same surface that the subwoofer is mounted to. So as long as that height dimension is more than that 1.433, we should be good to go. And I like to give myself a little bit of extra breathing room, so that's why I went with 1 3/4 inches. So when I go to actually create this piece in real life, I'll make it out of 2 3/4 inch pieces of wood. That will give me 1.5 inches, and then I'll add an additional 1/4 inch piece. Now for the next step here, again, based upon that that initial profile that I drew, I'm going to create this board here. This is going to be my mounting baffle for the subwoofers. It's simple enough, but you can see that it notches in following those quick corners. And the reason for that is this is going to give me a surface to attach some of these vertical pieces to. Stepping through to our next step here, I've just extruded this profile even higher, and I intentionally go much higher than I know the front of the enclosure needs to be. And that's because we're going to trim these off in the model much like we will in real life. So now that we have those added in, let's add the front and sides of our enclosure as well. I've simply drawn those in and extruded those. I'm going to be using 3/4 inch materials throughout the build of this enclosure, so I knew what I needed that extrusion to be, but we've got those added in now. So now that we have that front and two sides of the enclosure, let's go ahead and add ourselves in a rear panel of the enclosure. And now we can do the cut of that top surface. I want to show you guys really quick how I did that cut because this is important. We have to make sure and remember that we're going to add a 3/4 inch top piece to the top of this enclosure. So I don't want these values to be the total value that I want the final enclosure to be at. I want them to actually be 3/4 of an inch less. So since I know the rear of my enclosure needs to be 7 3/4, I've got 7 inches here. And since I know the front of my enclosure needs to be 11 1/4, I've got 10 1/2 inches here. Again, it's 3/4 inches less. So I've created this triangle profile here. And if I execute this command, you can see it makes that cut right there that's going to trim off the top of our enclosure. Now, the reason it's advantageous to work through this design process on a computer is now I know in real life that, this board here, I'm just going to make an angled cut like that. This board here, when I cut this top piece, I'm going to actually cut it at an angle on the table saw. And then we have some cool router trickery that we're going to use to make this complex cut on this stack of the rounded corners. If you guys want to see how I do that, definitely be sure to follow through the rest of this build. So now we can add the top panel of the enclosure, and when I'm designing on the computer, I like to build it like I would in real life. I think it'd be easy to extrude straight up and create a board that you wouldn't really be able to create effectively in real life. Instead, what you're going to do in real life is you're going to just cap this off with a sheet that is tangent to this top surface here. So you can see that's why it has this slight little angle to it. So in real life, I'll add that. I'll run a router on this top surface here with a flush trim bit that's going to pick up these side profiles. And I'll intentionally oversize this piece when I cut it in real life, and the router will trim it down and make it nice and flush. And then on the back side here, it wouldn't really work to oversize it and do that router trick that I was talking about. Instead, when I make this panel, I just need to make this angled cut on the table saw. So you can see I just did a small little cut extrusion. I'll show you the sketch. It's just a small little triangle right there that's going to remove that extra material from the model. So now we've got the main sides of our enclosure framed out. We need to start adding some cutout holes. And first I want to add that cutout hole on the front of the enclosure that's going to allow some of that energy transfer out from the subwoofers. And with that in place, I want to make the actual subwoofer cutout holes. Now the design of this cut is very important. It would be simple to just model the actual cutout holes for the subwoofers and think you're good to go, but you also want to double check and make sure you have clearance for the outside flange of the subwoofers as well. What's unique about the JL Audio thin line subwoofers, the TW1, the TW5s, the TW3s, in this case these are the TW5s, is they have this tab ear design. And this is actually a really nice feature. What these tab ears allow you to do is have enough room on the flange of the subwoofer to actually be able to physically bolt it in, but by only having those mounting holes in certain locations instead of all the way around the subwoofer, you can actually put two subwoofers a lot closer to each other. So you'll see that this A1 dimension they have at 14.2 inches, and then the A2 dimension is 13 inches. So that A1 is the outside diameter of the tab ears here, and then the A2 dimension is the outside diameter of this circle that you see right here. So I can account for this when I'm doing my design process. You can see that I've drawn in a construction line circle that's 14.2 inches. That's the outside of the tab ears. And then I also have the 13 inches, which is the outside diameter of the actual subwoofer itself. And you can see that the tab ear diameters overlap, but I don't have to worry about them hitting each other because the tab ears are up in the corners of the sub. So I can effectively get these subwoofers closer to each other, which is valuable because we start to run into clearance issues as we get towards the outside of this enclosure. The final diameter circle I have in there, of course, is the 12.5 inches, which is my cutout hole size for the sub. So with the cutout holes now modeled in, now's a good time to check on our internal air volume. If you see this pink area here, that's actually a solid. If we turn on a quick cross-sectional area here, you can see that it's filled. It applied that wood texture, but that's actually that pink surface in there. That pink area is going to give me my internal air volume because it starts at the inside surface of our mounting holes here, and it's the same shape as that inside profile, and it extrudes up to the top surface of the enclosure. So what I can do is check my mass properties here, and I can select that exact body for our volume calculation, and I can see that that gives me 4,199 cubic inches internally to work with. So if we take that 4,199 cubic inches and we divide it by 1728, that allows us to convert to how many cubic feet it is. That's because 1728 is how many cubic inches are in a cubic foot, and that gives us a value of 2.43 cubic foot of air volume inside of here. Now we have to remember though that there are other things inside this air volume that are going to use some of it up. Notably, there's the subwoofers, but there's also going to be that bracing. So let's get that modeled in as well. To model in this window bracing, I simply drew that outside profile, and then I drew these inside windows and extruded those particular areas there. Just to give you an idea, this dimension here is going to be 3/4 of an inch. So along with the braces being 3/4 inch thick, because I'm making them for 3/4 inch sheet, I'm also going to have a 3/4 inch frame width, if you will, on all of these dimensions. The reason it's good to model in these window braces is we can once again determine their exact internal volume. If I check the properties of one of these internal braces, it is 23 cubic inches. I've got 2 of them, so that's going to be 46 cubic inches of offset. We've been discussing in terms of cubic feet, so we might as well do a quick conversion. 46 divided by 1728 is 0.026 cubic feet. If we go to our subwoofer spec sheet, each of the subwoofers has a driver displacement of 0.052 cubic feet. So basically, to determine our air volume, we're going to take that value we had before of 2.43 cubic feet. We're going to subtract the 0.026, which is for the window braces, and then we're going to subtract 3 of the 0.052 because there's 3 subwoofers. And I've got my calculator here. That gives us an internal total of 2.248 cubic feet. Now hold on, Mark. I thought that our target air volume was 2.4 cubic feet based on the 0.8 times 3 recommendation from the manufacturer. Well, let's load up WinISD and do a quick analysis to see what this small volume change may do to our performance. So this white line here simulates the SPL that we could expect if we were using the suggested value of 2.4 cubic feet sealed, and this is at 1800 watts of power. Do keep in mind this is simulating an anechoic response. Let's see what would happen with the same 3 subwoofers at our value of 2.248 cubic feet, again at the same exact power of 1800 watts RMS. You can see that with this orange curve here, there is virtually no difference in performance between these 2 air volumes. In fact, on our white curve here, if we put the cursor at about 40 hertz, we have about 118.6. And if we switch to our orange curve here, we've got about 118.4. So a difference of about 0.2 decibels. And just to put that 0.2 decibels in perspective, you would be able to measure that if you were competing, but you would never ever hear that difference by ear. And do keep in mind that this is if you are at full tilt max volume. Moral of the story here, this small volume difference is not an issue at all. Now, while we're in the design process, it's also always helpful to do a quick subwoofer clearance check. You can see that I've modeled in a simulated subwoofer here, and I was able to do that simply by knowing the actual mounting depth of the subwoofer from our spec sheet. I've got that modeled in, and I could do a little section view for you guys really quick here. I knew already that on this enclosure, this is a non-issue just because I did do that seat lift and I do have so much room above the subwoofers, but you can see we verified here, we've got plenty of room behind the sub. So now that I've finished making the design, I can of course also export this in my blueprint format that has all of the overall dimensions of the enclosure, and you can see that this has 5 sheets. The other sheets give dimensions and details for each of the exact boards that you need to cut in order to make this enclosure. If you guys would like to get this pre-made blueprint, you can purchase it on my website. I'll put a link for you guys down in the video description. So now that we have the subwoofer enclosure itself figured out, I do want to add some additional design details in order to make this enclosure more unique. So I need to design those as well, and of course build this whole enclosure. So if you guys want to see the full process, be sure to come back to the channel for that. Don't forget, next time you need assistance picking out car audio gear that will perfectly fit your vehicle, be sure to check out our show sponsor Crutchfield with their vehicle selector tool and take advantage of those special offers linked down in the video description. A big thanks to them along with Jerry and the Patreon membership team for making these videos possible, and thank you guys so much for tuning in and watching.